2.4, our objective today is to write linear equations. There's a couple ways we can write equations. If we have the slope and the y-intercept, the easiest equation to use is y equals mx plus b. Just plug in your slope, plug in your y-intercept, done. Normally we won't have a slope and y-intercept. We'll have a slope and a point. You can still use the y equals mx plus b formula, but this other formula called the point-slope form is easier because it uses the point and the slope. Y minus y1 equals m times x minus x1. M is your slope, x1 and y1 is your point. Sometimes we're not given a slope at all, then we have to use either one of those formulas, but first we have to get the slope. So we calculate slope first, then we go back to point-slope form, ideally. You could also use slope-intercept form, but that's not what the cool kids are doing. Point-slope form is the easiest. So looking at this first example, it says write an equation of the line. Looks like we have a slope. It's given to us pretty much. We can see looking at the picture there, our rise is 3 and our run is 4. We also have the y-intercept. That's where the graph touches the y-axis, -2. Looks like the winner this time is y equals mx plus b. M is 3/4. B is -2. Done. At this point, you can pause the video and try these on your own, or you can wait and do them later. This time we're not given a y-intercept, we're given a point and a slope. That should set off the warning in your head to use the point-slope form. Just plug in the numbers, clean things up, and you're done. Notice I actually had an equation of a line once I got here. I'd give you most of the credit on a quiz or a test if you stop there, because that actually is an equation of the line. It's just not simplified. We consider this simplified once we get y by itself. This next problem is asking us to do two things. In part A, we want to draw a line that is parallel to -4x plus 1. So that tells us our slope should be -4. And our point, which is given to us, is -2, 3. Part B says to do almost the same thing, except we want a line that is perpendicular. So instead of -4, we use the multiplicative inverse and the opposite. So the opposite inverse, and we get +1/4. But I'm using the same point. From here, you go through your point-slope form again, and you get your two equations of your lines. I suggest you try this on your own. I'm going to put answers. Part B is naturally a little bit more difficult because of the fractions, but don't get too scared. They're not even a whole number. At this point, you can pause the video and try these on your own, or you can wait until later. Kind of our hardest version of the problem. This time we're not given a y-intercept or a slope. This is that type of problem where you have to figure out the slope on your own using our slope formula. Once we have that, we can use our point-slope formula. Notice this time we have 2 points to choose from. It actually doesn't matter which point I use. I can plug in the 5, -2 or the 2, 10. And once I simplify, I'll get the same exact final answer. If you don't believe me, try for yourself. These are the numbers you should have come up with. Once you get that equation, y equals -4x plus 18, you're done. Go ahead and pause the video and read this for understanding. Figure out what you're supposed to do. Looks like we're given a scenario where we're given a year paired with how many females participate in high school sports. For instance, in 1993, we've got 2 million people. We've got to be mindful of our units here before we give a final answer. Later, we see in 2003, we're up to 2.86 million. We're supposed to write a linear equation that models female sports participation. To do that, we'll need a slope. We know how to find slope at this point. Once we have a slope, we can use our point slope formula. We get our equation at this point. It's always good to think about what it really means. So we could plug in a year. We'll probably want to plug in a year past 1993, or at least not too far before it, because the further we get away from the data, the less accurate it's going to be. For instance, if I plugged in 0, it would say that we got negative 169.4. I'm pretty sure we didn't have negative 169 million people playing high school sports in the year 0. So this graph is only useful for numbers close to 1993 to 2003. But we could plug in something like 2013 and get an estimate for how many millions of girls are playing high school sports in the year 2013. At this point, you can pause the video and try these on your own, or you can do these later. Pause the video one more time to read over the problem and figure out what's going on. Looks like we're buying some songs and we have $30 to do it with. We might want to set up a couple of variables, like A would be how many songs we buy from company A. And similarly, B could equal the number of songs we buy from company B. Now we can set up an equation. We know we have a total of $30 to spend. And from that $30, we take however many songs we bought from A and multiply that by 79 cents. Take how many songs we bought from B, multiply that by 99 cents, and add it together. As long as we add those together and we get something that's not bigger than 30, then we did not spend too much money. At this point, you can pause the video and try this on your own. Other than that, we are done with this lesson.